I'm super, super honored that we have our next guest here. Vlad has been chasing him for quite a while, and we finally made it happen. So Tom Mason is the CTO of Stability.ai, the premier open source AI startup in the world. I'm sure many of you have used Dream Studio and all of the cool tools. I love playing with it. He leads the product development and engineering of the generative media platform at scale. And he has like something that I think many of us wish probably that we're doing. He's running a cluster of 4,000 NVIDIA A100 GPUs on the AWS cloud. I'd be very eager to run that. I'd not be very eager to pay that bill. But we can ask Tom how he's doing that. He's also the creator of DreamStudio.ai, a new AI system powered by Stable Diffusion that can create images, art, and animation from any description, natural language. So it's been really like one of the most powerful generative AI tools. And he had a storied career in technology. Before Stability.ai, he was a CTO at Chorus Intelligence, a global data platform for law enforcement, was a founder and CEO of the tech startup accelerator Usoft for over a decade. And I'm super, super excited to have Tom share his insights on computing large foundational models. Please all give a super warm welcome to Tom Mason.
Thank you so much for the amazing introduction. Thank you to Vlad and Philip for this amazing event and conference. You guys put on an amazing event. And thank you for inviting me to be here to speak. So I'm Tom, CTO at Stability AI. We are a research-led, open source aligned generative AI company working on computing large foundation models in all of the modalities that we're going to see this year and over the next couple of years. So we're trying to do some incredible things, and hopefully I can give you a bit of an overview of that today. So the first thing is, this is just getting started. It's been an incredible year, and the hype cycle's like almost like hard to keep up with on Twitter. But I can assure you, this is just the beginning. There are some incredible things coming. The predictions on the valuation of the industry are like off the charts. If you look at all of the different layers of the stack and the companies that are going to be building each of those layers, or operating across all of them, and Stability AI, we're trying to be that foundation infrastructure layer service. So we've got new companies evolving: OpenAI, Stability, Anthropic, Cohere, A121. Lots of these big companies now building big infrastructure platforms, foundational models, partnering with hyperscalers such as Google and Amazon and Microsoft. And what's incredible is the speed at which these models are getting faster, okay? So just to give you an idea, like a year ago, to generate a high-quality image at 512 by 512 would take 30 seconds, okay? And even longer, like with things like VQGAN and Disco Diffusion, sometimes minutes to create a decent high-quality image. This is now taking, like 6 months later, 9 months later, it's now taking a couple of seconds. And for diffusion models, this is because of a few things. The diffusion samplers are getting better. We're compiling the models into static graphs. We are improving the algorithms that do the diffusion process. And obviously, the GPUs are getting faster as well and cheaper. And all of these kind of factors and better models, more efficient ways of building the models are making this get faster and faster and faster. And so we're literally going towards like real-time diffusion, real-time generation of content. Right now there's this: put in a prompt, you get something back a few seconds later. This is just going to get faster and faster and faster. This is one of the things that's going to unleash different ways of controllability in the models. And the same thing is true with transformer-based models like ChatGPT. Or the language models. They're getting faster and they're getting bigger because we're working out how to split the models across different like sharding processes and different things. So all the companies in the creative industry and around are kind of in this crazy rush to get involved. We're all trying to work out what the best use cases are. Lots of them in the creative industry, some of them up here, like more surreal experiences, rapidly prototyping, better ideation, writing proposals, et cetera, et cetera. So everyone is trying to find out what these models are going to be used for and how to get the most out of them. And this is now bubbling up to the largest creative agencies in the world, WPP, Microsoft, Adweek, PitchBook, they're all, you're seeing it everywhere. Jasper is a big client of ours, uses our API in their blogging platform to generate images, and so on. So stability is basically, our commitment is to open source. What we're trying to do is to democratize this technology and make sure that everyone can access it, and they can own the weights, and they can control it, and they can fine-tune it. And when we do that, we see this explosion of excitement and collaboration around the technology. And that is the thing that we feel is just like really important for this technology. It has to be in the wild and for people to be able to use it in their own way and with their own and control, and own the data and the sovereignty of the data. So we have a pretty cool team. We're about 150 people, started by Emad a couple of years ago, myself and the rest of the team. And then we have amazing research teams, David Half from Google Brain, Robin, who was one of the co-inventors of Stable Diffusion, Patrick from NVIDIA, Stanislav Fort from Anthropic, who's now leading our language models, and many other researchers who, many of them have come from small open source communities that have been working together and have needed some support to either get access to data or access to compute, and that's where we've tried to support some of those groups. We've been building a very big cluster with AWS over the last few years. So we have around about 4,000 A100s on AWS. We also have a secondary cluster with CoreWeave, and we're constantly building that. The H100, which is arriving in the next couple of months, is going to be a big advancement. We're going to see a minimum of like 3 to 4 times the performance of the A100, up to like 10 times with the right kind of CUDA optimizations. So the A100, is the big reason that NVIDIA's price is going crazy right now. The A100 has basically like powered the training of lots of these models. And there are other great chips that we use, like the A40 and the A10 from NVIDIA, which are all like fantastic chips for inference. So stability is kind of, the technology pillars are kind of made up of 3 different areas. Research, we have the teams that are working on building the foundation models. They're working on building data sets, curating those data sets, labeling them, training the foundation models, bringing them to convergence to a point where they can write an academic paper around them and release them back to the community to use them. And then we have applied ML, which is taking those a step further and fine-tuning them with our LHF and custom pipelines, looking at how we get data from enterprise, work with different partners to build proprietary models, which are really important as well for like video and audio, which I'll talk about in a bit. And I lead engineering, which is basically bringing those models to customers and serving up APIs, and then also building some of the infrastructure that we use internally around the high-performance cluster and data platforms. So Stable Diffusion we released back in September, and it's kind of exploded. We had this incredible explosion of different communities popping up on Reddit, Discord, GitHub. It's one of the most popular GitHub open source repos, and obviously Hugging Face now, where you can download a lot of different variants and fine-tune versions. We work a lot with Hugging Face. They're an incredible company, doing some incredible things with their kind of universe of models. So yeah, the GitHub graph for Stable Diffusion is kind of amazing. It just sort of shot up and exceeded Bitcoin within like 2 weeks, which was pretty incredible. And then lots of companies then starting to use the technology to build out their own platforms, both through our APIs, but also just through the open source models. Stability doesn't interact with every customer that uses Stable Diffusion, obviously, because it's open source. So you can just take it and you can run it. As Philip was telling me earlier, they're tuning it to make images of food for their company there, and lots of companies building on top of it. So we have things like Wombo, companies like Wombo Night Cafe, which were around before Stable Diffusion, but have now adopted it as their image generation model. Companies like Lensa, which you probably saw, which uses fine-tuning to inject yourself into the model. And I'll talk about that as well a bit, because fine-tuning is going to be a big thing for all the modalities. And then lots of other companies like ClipDrop. We acquired ClipDrop a few months ago, and they provide more like prosumer tools for replacing backgrounds or cleaning up images, using AI to augment images. So our latest model that we're working on right now is Stable Diffusion XL, which is awesome. It's a really, really amazing model. It's about, the base model is about 3 times bigger than Stable Diffusion, but it doesn't take up 3 times as much VRAM, through lots of different compilation techniques that, becoming a lot more optimal in the way that we're serving it. But yeah, it's about 3 times bigger, but it's aesthetically conditioned. There's a lot more preparation of the images that we're putting in there, and then aesthetically conditioning the model so we can tune it to produce great images on every prompt. So one of the things with Stable Diffusion is that you quite often there's a lot of tweaking, a lot of prompts, and you end up with a prompt that's like 3 sentences long. So that's no good. So basically, we're trying to work on, so it's really important for people to come to the model for the first time and put in a simple prompt and get a beautiful image back. And the images that are coming back from Stable Diffusion XL are amazing. We're gonna be releasing a 512 model, but also a 1024 native model, which produces 1024 images. Which with an upscaler, you can get to kind of 2K, 4K, in kind of 10, 15 seconds, which is amazing. And it also has a text encoder in it, so we can produce text with a label in the prompt to produce words and images, which is pretty awesome. So yeah, we have a few different modalities that we're working on, and there's really exciting things happening in each one. Stable Diffusion, obviously, Robin and the team there are working on multiple variants of Stable Diffusion. We have the Deep Floyd team, which we just released the model of about a month ago, which is a cascaded diffusion model I'll talk about again in a minute. Completely different type of diffusion model. We have a whole LLM team that's working on a range of different language models, from a 7 billion parameter model all the way up to a 65 billion parameter model, and those will all be open sourced. We open sourced the last one, Stable LM, about a month ago, and then Stable Vicuna, which is another variant of the LM models. Vicuna is one of the top open source models, and we're kind of really improving it very fast. We have a music team that's working on a voice conversion model, voice conversion platform, but also a music generation model, and I'll talk about that in a minute. Text to video, again, is going to be it's probably the area I'm most interested in, and it's going to be an incredible thing this year. And finally, text to 3D, which is a little bit further out, but super exciting. So Stable Music, we are working on voice conversion, but also music generation from 30 seconds up to a full song, with prompt interpolation, allowing you to basically plan out the full story of a song and training it on lots of licensed data that we're working with different music companies with. Stable Video, this is like an example from one of the models that we're training right now, which is proper true video diffusion. So there's lots of different techniques for generative video, and they've kind of come from animation, which is iterative transformation of images, and I'll talk about that a little bit. But we're going towards what we want to see, which is true video diffusion, which is basically trained on sequences of images over time, so it has an understanding of how things move. It has an understanding of physics, which is pretty crazy because you can kind of reverse engineer some of this stuff back out of the model, which is interesting. So Stable Video is going to be incredible. And then Stable 3D, we had teams working on text to 3D in the open source community 2 or 3 weeks after Stable Diffusion was released, using NERF models to generate 3D meshes of images directly from the Stable Diffusion model. So this is super cool, but it's very slow, and we need to make it faster and higher quality. So some of the animation teams, this is just a simple example of video to video, where you're taking one video and then you're augmenting that with style augmentation. This is Fight Club, but then augmentating all the faces. And there's been a lot of work on people trying to get coherence in the frames. So this is very difficult right now, trying to get coherence from frame to frame. And there's lots of ways of doing that with different coherence models, conditioning models like ControlNet and T2I, which I'll talk about. But this is a difficult thing to do well. And then Deep Floyd, this is the model I mentioned earlier. So this is our kind of latest completely different foundation model, which is a cascaded diffusion model. So it generates images at 64 pixels, and it has 2 stages of diffusion with latent upscalers that upscale that to 1024. So it's a little bit slower, but it produces fantastic images. It has a very large text encoder in it, so it can do incredible font generation in different styles, which is really, really difficult to do well. So it's incredible how well it came out. And because the first stage is like a 4.6 billion parameter model, so this is producing 64 pixels by 64 pixels with a 4.6 billion parameter model. So you're squeezing a lot of information into those 64 pixels. So it can do some really interesting compositional things like red squares on top of blue squares and all kinds of different control techniques. So this is a really amazing model. We released it just recently, but we're going to be releasing a couple of different versions of it over the next month. This is some examples of our voice conversion model. So if We can play the top YouTube one. I'm relying on my friend at the back to play it, if it's working. Here we go.
And like again, across all modalities now, in narrow, you're achieving human levels and beyond human levels of performance in benchmarks.
And like again, across all modalities now, in narrow, you're achieving human levels and beyond human levels of performance in benchmarks.
And like again, across all modalities now, in narrow, you're achieving human levels and beyond human levels of performance in benchmarks.
And like again, across all modalities now, in narrow, you're achieving human levels and beyond human levels of performance in benchmarks. And like again,
Okay, we can probably stop it. I think that's the last one, but
you're achieving
if we could stop it and then
beyond human levels.
and then there's just one more. So that's spoken voices, converting spoken text, and there's also like singing voices. So the one below, if we just play the original one on the left, we just play it for a few seconds. This is the original one, which is Amazing Grace, sung by a man. And if we stop that and play the converted version, this is, so then, yeah, we'll play this. Cool, that's good. So basically what's going on here is that this is an original singer, and then we've got Imogen Heap, who is a famous, you've probably heard of Imogen Heap, famous singer. So we trained a model on Imogen Heap's voice, and now you can give her any voice into that, right? So what this is great for is that music companies who own, the rights to all these artists can basically create models for each of those artists, and then any music producer, right, can then buy access to, to make songs, licensed songs with that singer's voice by converting someone else's voice into that, which is kind of an amazing idea.
Across all
So anyway, moving on. I've got to hurry up now because we're running out of slides. So we're doing lots of partnerships, Adobe, ByteDance. We do lots of integrations. Obviously, AWS we're doing loads with. The SageMaker platform's been a big thing. The ML learning platform that we're doing lots of work with our custom containers, where you can deploy Stable Diffusion directly into AWS on your own account. And obviously, they're launching Bedrock next month, which is going to be a big thing. It's their brand new foundation model platform. And we've got a lot of hardware manufacturers that are trying to use Stable Diffusion to become like the generative model on their device. Samsung, Qualcomm, Apple, they've all got like Stable Diffusion running on device, on edge, with like distilled versions of the model, which is pretty amazing. I mentioned Bedrock. Bedrock is going to be the foundation model platform for AWS, which is super exciting, and we're one of the launch partners for that, which is great. So yeah, moving on, we have a platform site, which is our API and allows you to integrate with all of our different models using SDKs, with JavaScript and Python and different things. We have a REST API, gRPC API, and lots of different things that you can do there around building bots and integrating with all the features of the service around image storage and persistent history. Then some of the things you can do with Stable Diffusion, which are pretty cool. So this is just an example of image generation where we've taken a logo, we augment it with some form of sketch, then we generate from that, and then we have different models like Unclip, which can do variations. So you can then control the structure of the model, structure of the image, and make different variations of it. We have our upscaler, the latent upscaler that I mentioned that's being used in DeepFloyd, which can do 4K upscaling, injecting new content into the image while retaining the overall structure, which is amazing. And then Dream Studio as well. You can try a lot of this stuff out in Dream Studio. Most of these features are available there. It's probably the easiest place to go and try Stable Diffusion and some of the other models as well, including Excel. We've got presets and lots of other things there. So fine-tuning is going to be a massive thing this year. We're just about to launch our fine-tuning API. Dream Booth was invented about 2 weeks after Stable Diffusion was released. Nathaniel Ruiz at Google built it for Google Imagen, and then someone transferred it and migrated it to make it work with Stable Diffusion. So this allows you to inject yourself into the model. The model doesn't know about me, doesn't know about most people. or my pet, my cat, but I can inject that into the model through a fine-tuning process that takes about a couple of minutes. We've been working really hard on a new technique called LoRa. LoRa is becoming a kind of fine-tuning technique for many foundation models, including language models, which is a much more efficient way of tuning the network with an external adapter that controls the weights that you're changing, rather than changing all of the weights of the model, which is really, really inefficient. That was the way that Dreamwidth originally started. So the fine-tuning pipeline does lots of work. It prepares your image, it crops it, gets the face in the right place, and then returns you your LoRa adapters and allows you to inject yourself into the image or into the model and produce lots of different images of you in different styles. So if you haven't tried this already, you should definitely have a go at it. It's pretty cool. I mentioned the animation API, and this is using like iterative transformations, so allows you to modify the images in lots of different ways. We've got prompt interpolation on the left, 3D translation on the middle, and 3D rotation on the right. And again, these are just slowly getting more and more coherent with little techniques that we're introducing. If you're familiar with things like Deforum, a lot of the creators of Deforum work at Stability, and we've been building this animation platform, which we just released. This is Revel, who use it in an app combined with fine-tuning to allow you to kind of make amazing animations of yourself in different styles. And we just launched a competition with Peter Gabriel. So he came to us and said, look, I'll give you guys license to all the music I made in the 80s, and we'll run this competition called Diffuse Together. And we invited basically all of the Discord, like 200,000 people, to all compete to see who could make the best video for one of his songs. So I'll just quickly play you the winner. We haven't published this yet, but this is amazing because they just combined like a whole bunch of different techniques. That it's took, a lot of work's gone into this, obviously many hours. So I'll just play you a couple of minutes of this so you can get a feeling of it.
911, what's your emergency, please?
Put your hand up, you make your bid. You got your pictures all laid out on the grid.
There's lip syncing, there's obviously a lot of stable diffusion, combination of different techniques.
That you never want found. And the chord will rise while the pillars all fall. We got the healer and the birthday cake. We got the whipping and we got the thing. We got the ladder, look, there is the snake. How my body begins to wake. And the chord.
Cool. Let's pause it because I'm going to run out of time. But yeah, just to make the point, like any one of you, right, could be working on this video. All the technology like exists right now, in either Deforum or the API. Obviously with a lot of video editing skills as well, quite impressive, but amazing. Let me just see if I've lost my clicker now. Clicker's not working. Oh, it is. Okay, cool. Right. I'm going to jump quickly because we got lots of integrations. We have integrations now with Google Slides, Blender, Adobe Photoshop. Obviously, lots of different things in Dream Studio. Let's quickly flick through these. So these are some of the other models that we produce and different techniques. One of the things that we've been working on a lot is controllability. Stable Diffusion depth to image allows you to take a depth estimation of an image and then use that to control the structure of an image that you're generating. So that's just one more level of controllability. This is Emad being transformed into a robot and also someone from Sesame Street. So just basic like depth structure maintenance. In painting allows us to remove a part of an image and replace that with something else guided by a prompt whilst keeping the rest of the image constant, which is great for controllability. This is an example of Game of Thrones 8. So we're reinventing Game of Thrones 8 as a Japanese drama. This is done by someone in the community who posted it, but it's really awesome. And hopefully we're going to do this with video soon. So we're going to be, the plan is to kind of make, Game of Thrones season 8 and other videos that will never otherwise exist because without generative AI. So controllability is a massive thing. We're trying to work out how to use all these different techniques to allow companies to generate new concepts, new ideation, to be able to inject the generative process into their existing like creation pipelines, creative workflows. And film and TV and video is going to be like the first area that we're going to see a lot of this coming in. Creative concepting, advertising, dubbing, storyline assistance, post-video augmentation. A lot of these things are things that are already possible right now. So, you know, replacing backgrounds in stills, you know, reshooting videos, and kind of moving from, you know, a kind of a social consumer culture of us like just doom scrolling on Twitter and video and YouTube to actually kind of creating some of that content ourselves and having more involvement in the creation process, which I think is kind of one of the most important things about generative AI, right? Is it's just given us the ability to take some time back to ourselves and to kind of enjoy the magic of this process, especially with image models. And this is going to happen with video models and audio models where we can control the audio or the media that we watch. To some extent. So this is, you know, a big thing for media companies that are trying to do concepting and ideation, content production, character development, scene creation. You know, if we want, we work with different film companies. For instance, Sony working on Mitchells and the Machines. We trained a custom model on the Mitchells and the Machines film, and then they were able to kind of, you know, do concepting and ideation of new scenes from the film. We basically just fine-tuned on each of the characters and fine-tuned on the aesthetic of the film. Then you merge those fine-tunes back together, and you get one model, which is basically like a Mitchells and the Machines model. And you can use that to generate, you know, new scenes from the film without having to kind of go through the whole 3D production process. And again, Stable LM, you know, and other language models will be used to do storyline creation, storyline existence, ideation, and that can be done by people that, you know, by users and consumers of the film that want to control their journey through it, right? So intelligent NPCs is a great example of Jensen from NVIDIA just posted this in his last NVIDIA video, you know, of a completely intelligent AI-driven NPC in a game where you've got, you know, the language model doing the conversational speech synthesis, doing the voice, and then obviously text to 3D or 3D generation of the mesh. So completely like generated characters in games. So that's pretty much it. Stability, we're kind of trying to change a lot of things and bring some amazing technology, and we're working really hard on it. It's difficult, like there's a lot of, the industry moves really fast, but we have some incredible researchers. We're very lucky to have a lot of support from partners. We have lots of different ways of using the technology, from our API to our preferred program, but you know, our aim is to really bring this open source technology to you know, all of the countries of the world. You know, right now, these language models and the diffusion models, they're very Western based. They don't work in other languages. We want to bring the technology through the open source kind of alignment to national, public sector governments, and to other companies around the world to make it local to all of the people in the world that should be able to enjoy this technology. So that's all from me. Thank you very much. Sorry I went over time, but yeah.
That was awesome, Tom. So much appreciated. Really, really cool stuff.